Can cosmic microwave background radiation be a universal temperature? Have you ever wondered if there is a temperature that applies to the entire universe? This question leads us to the cosmic microwave background radiation, often referred to as CMB. The CMB is the thermal radiation that fills all of space and is a remnant from the early universe. It provides a fascinating glimpse into the conditions that existed shortly after the Big Bang. The temperature of the CMB is approximately 2.725 Kelvin, which is just above absolute zero. This temperature is not random. It is remarkably consistent in every direction we look in the sky. This uniformity makes it a strong candidate for being considered a universal temperature. In thermodynamics, temperature measures the average energy of particles or radiation. The CMB is a form of blackbody radiation. Blackbody radiation is emitted by an idealized object that is opaque and non-reflective, maintaining the same temperature throughout. The CMB fits this description perfectly on a cosmic scale. Its thermal blackbody spectrum corresponds uniquely to its temperature of about 2.725 Kelvin. This temperature is not just a local measurement. It reflects the state of the universe around 380,000 years after the Big Bang. At that time, photons decoupled from matter and began traveling freely through space. As the universe expanded, the original radiation, which was much hotter, stretched to microwave wavelengths and cooled down to this lower temperature. While the CMB is mostly uniform, there are tiny fluctuations in its temperature. These variations occur at a level of 1 part in 100,000 and correspond to slight density differences in the early universe. Although these small changes are important for understanding how galaxies and large structures formed, they do not significantly change the overall uniform temperature background. From the perspective of thermodynamics and temperature scales, the CMB serves as a natural reference temperature. It is measured in kelvins, the standard unit of temperature. This example illustrates that temperature can apply not just to everyday objects but also to radiation fields throughout the cosmos. For cosmologists and physicists, this universal temperature is essential. It sets a baseline for the thermal state of the universe and helps validate models regarding the Big Bang and cosmic evolution. The CMB demonstrates how temperature scales can be relevant on a universal scale, making the principles of thermodynamics accessible to everyone. In essence, the cosmic microwave background radiation can indeed be viewed as a universal temperature. It represents the thermal state of the universe as a whole, characterized by a nearly uniform blackbody temperature of about 2.725 Kelvin across all directions in space.